I am Aylin Caliskan, and today I'm presenting our work on how contrastive language vision AI models, pre-trained on web-scraped multimodal data, exhibit sexual objectification bias. This is joint work with my co-authors from the University of Washington. I would like to mention in advance that the content in this talk might be upsetting or triggering. In 2021, we have shown that image embeddings trained on data collected from the internet contain human-like biases. A model such as IGPT is able to take a segment of an image and autocomplete it to generate realistic outcomes. Given a synthetic white male face, the autocompletions feature typically career-related attire. However, given a synthetic female face, the autocompletions feature bikinis or low-cut tops, and sexualization is amplified in racialized context. To understand gender associations, we also turn to language representations, namely word embeddings. Here we see the most frequent 1,000 words in the lexicon of GLOW. The greener the point, the more male-associated it is. 77% of the most frequent 1,000 words in GLOW are male-associated, and this imbalanced pattern persists over the entire lexicon and in other language representations that are trained on data collected from the internet, suggesting that the language of the online English-speaking world reflects the values and perspectives of men, providing large-scale empirical evidence for a masculine default in online English. But how do machines perceive the two fundamental groups of men and women? We take the 1,000 most frequent male-associated words to cluster them into male-associated concepts, which are adventure, big tech, engineering, cars, electronics, God and religion, scientific metrics, sports, war, and violence. And for women, the 1,000 most frequent female-associated words cluster into concepts such as advertising, beauty and appearance, modeling, cooking and the kitchen, fashion and lifestyle, relationships, obscene adult material, sexual profanities. Why are these the main representations of the two fundamental groups in society for machines? Why is AI trained on data collected from the internet sexualizing women? To analyze this in detail, we turn to the definition of sexual objectification of girls and women, which is the treatment of a person as a body or a collection of body parts. Human characteristics such as emotions, thoughts, and intentions are less likely to be attributed to objectified individuals. When women are visually depicted in sexualized contexts, they are also described as bodies or as sexual objects. And this is societally consequential because it is known to be directed toward adolescent and teenage girls, causing self-objectification and negative mental health effects, and impacts the careers of professional women. So in the context of these definitions, we will study sexual objectification using the sexual objectification database, multimodal language vision clip models, a clip-guided captioning system, images from professions, and text-to-image generators such as VQGAN Clip and Stable Diffusion. The sexual objectification and emotion database contains 28 photographs, each of 10 white women in objectified and non-objectified states, expressing emotions such as anger, sadness, happiness, with low and high intensity. I would like to mention that we have ongoing work on non-white, non-female associations as well. And we use CLIP, which is a multimodal space that is trained to maximize the similarity between image text pairs that are collected from the internet to train multimodal embeddings that can directly be used for zero-shot classification tests or many AI applications built on CLIP. And we specifically use the multimodal language vision space so that we can embed images as well as text stimuli that correspond to human characteristics or profession-related content, to study objectification bias with the embedding association test to measure the relative association of non-objectified versus objectified individuals with emotion or no emotion by constructing target sets of, for example, 20 images of non-objectified individuals displaying the emotion, 20 images of objectified individuals displaying anger. And we do this for emotions such as anger, sadness, and happiness. And we also have the corresponding text stimuli for emotion and no emotion to extract the embeddings for the objectified and non-objectified individuals, and also the text stimuli for emotion, no emotion, to measure their relative association and to obtain an effect size of D, to find that clip models disassociate emotion from images of objectified women, especially for anger and sadness. For happiness, we don't have significant results, and we hypothesize that might be due to selection bias on the internet, and overall, maybe women's images on the internet are happy, but we cannot make conclusions here because we don't have access to the training set, and due to lack of transparency, scientific inquiry is limited in this case. To analyze why emotions get disassociated from the images of objectified individuals, we use saliency maps, GradCam in particular, which is able to highlight pixels in images that correspond to the text prompt, such as a photo of a happy person and a person in a non-objectified state expressing happiness. We see that pixels on the face where emotion is expressed get highlighted, whereas for individuals in objectified states, the model gets distracted to partially clothed areas away from the face, which might be causing the disassociation. And this happens for anger, sadness, and happiness. Then we turn to captions generated for images of women in objectified and non-objectified states expressing emotion to measure if captions contain emotion-related words, emotions which are human characteristics. And we see that overall captions are less likely to describe the emotions of an objectified individual. The first bar here is the number of emotion-related words in the captions of images for non-objectified women expressing anger, whereas the second bar that doesn't exist is the number of emotion-related words in the captions of images of women in objectified states expressing anger. We also want to analyze how these might be related to profession associations, and we built on Marini and Benagi's work on gender, sex, and profession associations by constructing target sets with images of female scientists and male scientists, and use sex stimuli and science or profession stimuli from the medical domain, for example, with doctors, or from the business domain with CEOs, to find that across 3 professional domains, images of professional women are associated with sex over career when compared with images of professional men. And this raises significant concerns because such models are used for consequential decision-making systems, such as automated job candidate assessment that determines life's outcomes and opportunities. However, these are proprietary systems which we cannot scientifically study to analyze how these biases might be propagating to decisions. And we turn to another application, text-to-image generators. Given a prompt such as a 16-year-old girl, a 17-year-old girl, the majority of the images are sexualized, and this does not happen for the images of boys. This raises significant ethical as well as legal concerns, and this is concerning for the type of impact it causes on individuals and society. And a similar case caused public outrage recently. The AI-based photo editing tool Lensa is found to sexualize the images of anyone who doesn't identify as male, and racialized sexualization was even more prominent. And this raises many questions about how we can study AI bias, what kind of impact AI bias has on society, how we can mitigate these biases in socio-technical systems that require policy intervention, raising public awareness, as well as technical approaches to study bias, mitigate bias, have better data curation strategies for systems so that they can be trained with data that is aligned with the task the system is supposed to perform. We have many open questions in this domain where we need more transparency and transparency enhancing algorithms to be able to study these complex socio-technical questions. Please feel free to reach out if you have any questions.